Today we'll be looking at translations and reflections. To begin, we'll look at vertical translations, so where we're graphing y equals f at x plus q. The function y equals f at x plus q is a vertical translation of y equals f at x. The q indicates how many units that the function is going to shift up or down vertically. If the function is y equals f at x plus q, the function shifts up. However, if it's minus q, it's going to shift down. So now we will begin looking at an example of this. In this example, we want to sketch the following functions on the grid. The first function we want to graph is y equals x squared. Again, from yesterday's note, I'm hoping that we're all getting a hang of our base functions, where it is very important to remember these. So we first have y equals x squared. This function is a quadratic function, a parabola, something is very familiar with since grade 10. So we can graph our key points here, so 0, 0, 1, 1, and 2, 4. Again, if I'm moving too fast with my graphing, you may do a table of values, but I please would like you guys to all get very used to doing this all on your own and memorizing your base function. Remember to label y equals x squared. Now the next function that we want to look at here is our y equals x squared plus 2. Now what is this plus 2 going to do? This plus 2 is going to move our whole base function move up 2. So each point is going to move up 2 units, and that's 2 units vertically. So we have our point now at 0, 2. Instead of 1, 1, it's now going to be at 1, 3. And this point that's at 2, 4 will now be at 2, 6, which is off our graph a little bit there. Similarly, on the left-hand side of our parabola, instead of negative 1, 1, we will now have negative 1, 3, and negative 2, 6. And now we can go ahead and connect our points, and again make sure we label y equals x squared plus 2. And now the final function we'd like to graph here is y equals x squared minus 4. Now what does that minus 4 do? That minus 4 is going to move our base function down 4 units. So again, start with our base function. Remember, our base function is our y equals x squared, the pink one here. So our new origin, instead of 0, 0, is now going to be at 0, negative 4. And then we can move each point down, so it would be at 1, negative 3, and 2, 0. Similarly, on the left-hand side of the parabola, negative 1, negative 3, and negative 2, 0. Connect all of our points, and there we have our vertical translations. And always be sure that you label your xy axes and each function on the graph. Now we begin looking at horizontal translations, and this is when we're graphing y equals fx minus p. The function y equals fx minus p is a horizontal translation of y equals f at x. The p indicates how many units the function is going to shift right or left. So if the function is y equals fx minus p, this function is going to shift right. And similarly, if it's plus p, it's going to shift left. One way that I like to think about it is when it comes outside of the brackets, it's going to change its sign. So now let's look at our actual graphs here where we're sketching. So let's sketch the following functions on the grid. So we have our function here, y equals 1 over x. Again, this is a base function where we do have a vertical and a horizontal asymptote. Now, we're only really worried about our vertical asymptote right now, since we're only moving left and right. So our vertical asymptote here is at x equals 0. And we'd also have our horizontal at y equals 0. So recall from our base functions yesterday, we have some key points. And those key points are 1, 1 and -1, -1. Now remember, with this type of function here, it's going to come really, really close to our x and y axes, but it's never going to actually touch or cross. And make sure that we label y equals 1 over x. Next, we are going to look at graphing our y equals x plus 3. Now, looking here, we have plus 3. And what does that plus 3 going to tell me? It's going to tell me that my graph is going to move left 3. Also, to find your vertical asymptote, what you're going to do is set your whole denominator equal to 0. So you'll have x equals -3. So we can draw in our vertical asymptote there at x equals -3. And then each of our points is going to move over left 3 units. So now we will have it at our point -2, 1 and -4, -1. Remember, it's never going to cross or touch our asymptotes, but it will come very, very close to them. And make sure we label y equals 1 over x plus 3. Now the next function that we're going to look at graphing together is y equals 1 over x minus 2. Now what does that minus 2 tell us? That minus 2 tells us that we're going to move right 2 units. Also, to find our vertical asymptote, you're going to set your denominator equal to 0. So we get that x is equal to 2. So let's draw in our vertical asymptote there, and then each of our points from our base function, which is this pink function here, are going to move 2 units to the right. So we now have our point at 3, 1 and 1, -1. Again, it's not going to cross or touch our asymptotes, but it will become very, very close. And make sure that we label y equals 1 over x minus 2. So now let's put that all together. Let's look at our vertical and horizontal translations. So when this happens is when we're graphing our y equals fx minus p plus q. So the function fx minus p plus q is a vertical and horizontal translation of y equals f at x. So again, we want to graph the following functions on the grid. So let's first begin with y equals x squared. This is just our base function. So we can just plot our points there quickly and graph them. So that's our y equals x squared. And next what we're going to do is we're going to look at our y equals x minus 3 squared plus 2. Now what does this do? What does this 2 tell me? The 2 here tells me that we're going to move up 2. And what does this -3 tell me? It tells me that we're going to move right 3. So each of our points from our base function, we're going to move right 3 up 2. So starting at the origin, we're going to move right 3. So 1, 2, 3, up 2, 1, 2. And we get our point here at 3, positive 2. And then similarly with our other points here. And we're going to be off the graph a little bit. If we had bigger graph paper, we'd be able to see a little bit more of our points there. But as long as you're able to move right 3 up 2, that's what we're trying to do and get the hang of it there. So next we're going to look at y equals x plus 2 squared minus 3. That minus 3 is going to tell us that we're going to move down 3. And this positive 2 tells me that we're going to move left 2. So remember, always start with your base function. So in this case, that is our blue parabola here. So starting at the origin, we're going to move left 2 and down 3. So we get our point now to be at negative 2, negative 3. And we similarly can do each of the other points here. And last point. And then we can graph them. And again, make sure we label. We'll go back and label the second one as well. Forgot to do that one. And that is that function. Again, let's look at another example. So let's look at sketching the following functions on our grid here. So we have our base function, y equals the root of x. So when we're looking at the root of x, we have some key points. So 0, 0, 1, 1, and 4, 2. Okay, so that is our base function. So the green is our base function, y equals root x. And what we're going to do is we're going to work from there with our next functions. So next one that we have is y equals the square root of x plus 4 minus 1. So what is that plus 4 going to do? That plus 4 is going to tell me that we are going to move left 4. And this negative 1 is going to tell me we're going down 1. So from your origin, move that point from 0, 0, left 4. So that takes us to negative 4, down 1. So we get our point to be negative 4, negative 1. Similarly, with our point 1, 1, you're going to move left 4, down 1. So we're at negative 3, 0. And similarly, at this point here at 4, 2, left 4, down 1 takes us to 0, 1. And we can connect those. Make sure we label y equals the square root of x plus 4 minus 1. And the last function that we're going to look at here is y equals the square root of x minus 1 plus 3. Now what does that plus 3 do? That plus 3 is going to move it up 3, and that negative 1 is going to move it right 1. So again, starting from your base function, so our green function here, we're going to move right 1 and then up 3. And we have our other points that we can also graph here. Connect them. So our last point there is off our grid a little bit. And make sure we label. Now if you're getting a little bit, oh my goodness, this is a lot because I don't know my base functions, the more practice you do, the better you're going to get with this. So now let's look at some vertical reflections. The function y equals negative f at x is a vertical reflection of y equals f at x. So what we want to do here is we want to graph and label the following. So let's graph our base function y equals x squared. So this function 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Connect our points. And this is y equals x squared. Now, what is that negative in front of our x squared going to do? That negative is going to create a reflection about the x-axis. And what do I mean by that? Are our x values going to change at all? No, our x values won't change at all here. So the x values, okay, of the coordinates stay the same. So what is happening here is our y values change signs. So instead of being positive as it is in our y equals x squared, now all of those y values are going to be negative. So looking at our first point here, so at negative 2, 4, that point now is going to be at negative 2, negative 4. Okay, you can see this if you were to put in y equals negative and put in our negative 2 squared. That squared is only applied to the negative 2. So we have the negative in front, which becomes negative 4. Similarly, our point here at negative 1, positive 1 will become negative 1, negative 1. Now, will our origin change at all? 0, 0? No, it will stay 0, 0. And our point now from 1, 1 is now going to become 1, negative 1. And 2, 4 is now going to become 2, negative 4. And now we can connect all those points and make sure we label, so y equals negative x squared. Now let's look at another example of our vertical reflections. Now what we want to do in part B here is graph our y equals the square root of x minus 1 and y equals negative square root of x minus 1. Now, it doesn't ask us to actually do our base function and graph it, but we can graph our base function of y equals the root of x. So that will be at 0, 0, 1, 1, and 4, 2. Now, if you know how to graph it without having to graph our base function, please go ahead and do so. So that's just our y equals the root of x. Now let's look. What does this negative 1 do? That negative 1 is going to move it right 1 unit. So each of our points are going to move 1 unit to the right. So that is our y equals the root of x minus 1. Now, what is this negative in front of our whole function going to do? Similarly, from our example above, it's just going to have a reflection about our x-axis, when what that means is all of our y values are going to change signs. So instead of being positive, they are now going to be negative. So this point here at 1, 0 is not going to change. It's going to stay the same. The point that we have at 2, 1 is now going to be 2, negative 1. And the point that is at 5, 2 is now going to be at 5, negative 2. So the only thing that is changed here are the signs of our y values. And make sure you label. And now let's go ahead and answer some of these questions. Which axes were the equations reflected in? I've said it numerous times now, so I'm hoping we've caught on to that. So the x-axis. Were any of the points unchanged in the reflection? Yes? If so, which point? The point where y is equal to 0. So it doesn't matter what the x value is, it's just that wherever y is equal to 0, that point is actually going to be unchanged. So points that remain unchanged in a transformation are said to be invariant. Were there any invariant points? As we discussed already, yes. Where are the unchanged points found? So they're found on the x-axis at y equals 0. Now the last thing we're going to look at today is horizontal reflections. So the function y equals f at negative x is a horizontal, sorry about that should say horizontal reflection of y equals f at x. So we want to graph and label the following. So our first function we want to graph is our base function y equals x squared. So 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. Remember, always label y equals x squared. Now the next function that we want to graph is our y equals x minus 2 squared. Now what is that minus 2 going to do? It's going to move our function right 2 units. So we're going to take each point, move it right 2 units to get the following. So now we want to look at our last function here, and that is our y equals negative x minus 2 squared. So what this is that we have because this negative in front of the x is a horizontal reflection. Now, unlike a vertical reflection where our y values were the only things changed, here our x values change signs. So if they are positive, they will now become negative, and vice versa. So if we have our point here at 0, 4, think about what value will change. The value that's going to change is our x in this case. Our x is 0, so our point is going to stay at 0, 4. Here we have our point 1, 1. So now it's going to become negative 1, 1. So the only thing I'm doing is I'm changing my x value. Our vertex here at 2, 0 is now going to be at negative 2, 0. And our next point here at 3, 1 is now going to become negative 3, 1. And our last point here that is at 4, 4 is now going to become negative 4, 4. We can connect those and make sure that we label y equals negative x minus 2 squared. So what you notice here in a horizontal reflection is that our x values change sign, not our y values. So now let's look at our last example here, we have y equals x plus 2. Now this is just a linear function here, so we have that this whole plus 2 here actually moves our whole line up 2. So we have the point at 0, 2, 1, 3, 2, 4, negative 1, 1, negative 2, 0, and we could go further, but we don't need to. We can connect those points, and we can label y equals x plus 2. So now in y equals negative x plus 2, the same thing is going to happen as it did before in our last example. Each of the x values now will change sign. So if they were positive, will become negative. If they were negative, positive. So notice that the point here at 0, 2 will stay the same. We'll have the points all change. And what we get is that we have a reflection about the y-axis. So that's our line y equals negative x plus 2. So now we can fill in these questions here. Which axes were the equations reflected in? The y-axis. Were there any invariant points? Yes. And where were those points? Those points were any on the y-axis. So this is where x is equal to 0.